Hi. In the last class, I discussed the graphs and two concepts I covered. One is slope, another one is area. Now let us see the applications. I have shown one graph before you which represents two bodies moving with constant acceleration and starting from rest. The question is, which of the two bodies has greater acceleration? Suppose you read the question like this. Your first choice should be to think of either area or slope. Let us see slope. As I told you, slope gives y by x, which is v by t. So in this graph, the slope is equal acceleration, velocity by time. And from the graphs, it is clear that line 1 makes greater angle with the x-axis than the line 2. So slope of the line 1 is greater than that of the slope 2. So acceleration of body represented by line 1 is greater than the acceleration of the body represented by line 2. So this is how a question on slope related aspect can be answered. I am presenting to you another graph before you. This is a graph with potential difference plotted on y-axis, current is plotted on x-axis. Question is like this. Suppose a question is set like this. The two lines shown in the figure represent two wires of same material but having different resistances. Which of the wires has higher resistance? Options may be something like line 1, line 2. Both of them have equal resistance. Answer 4, option 4, data insufficient, something like that. Now let us see again. What does the slope give? First let us think of the slope. If the slope does not give our parameter, then we can think of the area. Slope is equal y coordinate by x coordinate. That is, in this case, v by I. From Ohm's law, we know that it is nothing but resistance. So, the ratio of resistances R1 is to R2 is equal to slope of line 1 is to slope of line 2. So, line 1 makes 60 degrees with x-axis, line 2 makes 45 degrees with x-axis. So, R1 is to R2 is equal tan 60 is to tan 45, which is equal to root 3 is to 1. So, the wire represented by line 1 or wire 1 has higher resistance than wire 2. So, this is how. So, the purpose of this discussion is the moment a question is set on graph, I already told you, you got to think of four aspects. Either it's a question related to slope or area or shape, nature of the shape or interpretation of the shape. Now let us see, I am telling you about the concept of area. In front of you, there is a velocity time graph with velocity plotted on y-axis, time on x-axis. Of course, the graph is visible in front of you. Now let us say, from this graph, I want to explain two or three different ways of, or two or three different aspects of with the same example. So, I want to explain with this graph how to interpret the shape of a graph, how to talk about the slope of a graph, how to talk about the area of a graph. Now let us see. The graph is OACE. See, these are the outer letters. Now, two more letters I have shown on the graph. One is B on x-axis, another one is D on x-axis. Now let us see. From the same graph, we will discuss two or three different questions, very important aspects. First one, what is the acceleration of the body at time t is equal 1 second from the graph shown in the figure? This is a possible question. Let us see. Now, as I told you, let us think of the slope. What does the slope give? v by t, which is nothing but acceleration. So, our solution lies with slope. Now, let us see the triangle OAB. In this triangle O to B is 2 seconds. We asked the acceleration at t is equal 1 second. So it is clear from the figure that slope of the line OA will give us the acceleration at t is equal 1 second. So from triangle OAB we'll calculate tan theta, which is equal to AB by OB, which is equal to 10 by 2, which is equal to 5 meters per second square. So the acceleration at t is equal to 1 second is 5 meters per second square. Many of the students, while calculating this kind of slope, usually have some doubt. The question is on acceleration at t is equal to 1 second. Then why did we take 2 in the denominator? So the thing is, OA is a straight line, so wherever you calculate, slope should be same. If you take 1 second on the x-axis, automatically the velocity on y-axis should be 5 meters per second proportionately. Again, your answer will be same. So that's bit 1, we solved it. And bit 2, let us ask another question. A graph for velocity on y-axis and time on x-axis is shown in front of you. Calculate the distance covered by the body in 8 seconds from the start. It's the graph for a body moving with a constant acceleration along a straight line. This is the question. Now, as I told you, let us discuss 2 aspects. First, let us think of what does the slope give? B by t, acceleration. No, it's useless. The question is on distance. Now let us think of the area of the graph. Area is equal y coordinate into x coordinate. So v into t will give us the distance. So our solution lies with calculating the area. So we can easily calculate the area under the graph OACE bound by x-axis, and this gives us the distance covered by the body in 8 seconds from the start. Right. So one bit regarding slope, another bit related to area we covered. Now with the same graph, I'll explain how to go about the interpretation of the graph. If you see the graph, from O to A it's a straight line. From A to C it's a straight line parallel to x-axis. From C to E it's a straight line again. Now OA is a straight line with positive slope and CE is a straight line with negative slope. Next point, I am explaining to you in a number of steps. Slope gives acceleration. Now let us start the interpretation. At t is equal 0, velocity is 0. And at t is equal 2 seconds, velocity is 10 meters per second. At t is equal 4 seconds, velocity is still 10 meters per second. At t is equal 6 seconds, velocity is still 10 meters per second. At t is equal 8 seconds, velocity is again 0. Now, O to A, slope is positive. A to C, slope is 0 because it makes 0 angle with x-axis. And C to E, it's a line with a negative slope. So, if you join all these points, if you connect the dots, you will come to a conclusion. Body is moving with constant acceleration from O to A, with constant velocity from A to C, with constant retardation from C to E. So if you interpret the whole graph, it will tell you that it represents a body moving with constant acceleration up to 2 seconds, then moving with a constant velocity up to 6 seconds, then it represents a body moving with constant retardation for another 2 seconds, and finally it represents that the body has come to rest. I am explaining again. The graph represents a body starting from rest and moving with constant acceleration up to 2 seconds. It then moves with a constant velocity from 2 to 6 seconds. And then from 6 to 8 seconds, it represents a body moving with constant retardation, and finally that the body has come to rest at the end of 8 seconds. So this is how the graph represents a one wealth of information for you. This is what do I mean by interpretation of the graph. So if you look at a graph, three things I have covered with the same example. How to think of the slope and calculate, how to think of the area and calculate, how to think of the interpretation of this shape. So a graph reveals a wealth of information. Now the same graph can be given by changing the y and x parameters. Your interpretation, your style of working does not change. Your logics do not change. The end parameters may be different, but your style of interpretation remains same. So this is with regard to the slope and area and shape, interpretation of the shape also. Now with regard to interpretation of the shape, I want to tell you one funny question. I call it funny because for specific reason, I'll tell you later. Most of you in modern physics must have studied a graph for BEPN, binding energy per nucleon versus mass number. So BE by A, average binding energy per nucleon, is plotted on y-axis and mass number is plotted on x-axis. I have shown the graph in front of you. I have seen this question repeating several times in different competitive examinations. Now I want to tell you what do you mean by interpretation of the graph. Now the question, first I'll tell you the question and the options also. Then I'll tell you why I called it a simple and rather a funny question. A graph is plotted for average binding energy per nucleon versus mass number. From the graph we can conclude that as mass number increases, the average binding energy per nucleon, option 1, continuously increases, option 2, continuously decreases, option 3, increases and then decreases, option 4, remains constant. If you just ask me, I tell you, honestly, this has got little to do with physics than with the interpretation of a graph. A student who is conversant with how to read x and y parameters, how to understand the shape of a graph, can easily answer this question. See, go on taking a pencil and go on observing. As you move from 0 towards the end of the x-axis, the x-coordinate goes on increasing. If you see the graph, the y-coordinate goes on increasing, of course with some irregularities, leave it aside because that option is not there. So as x-coordinate increases, the y-coordinate continuously increases, reaches a maximum and then decreases. So our choice will be option 3, first increases and then decreases. So even if you take the y and x parameters, anything else, for instance, y I can say the population of a country, x I can say years, or y I can tell food prices in our country, and x coordinate years from 2000 onwards, something like that. So if the question is, if the parameters are changed, our style of answering does not change. Let us say from 2000 onwards, as the years pass by or as time passes by, the food prices go on increasing, reach a maximum and then go on decreasing. That is the answer. So I called it funny because it's a very simple question. Who has a little knowledge of interpretation of graph, which he or she must have learnt in 9th and 10th class, is enough to answer this question. So this is what I meant by interpretation of the graph. The last one is nature of the shape of the graph. For all directly proportional quantities, you will get a straight line. For all inversely related quantities, you will get a rectangular hyperbola. For instance, a question is set like this. A body starts from rest and moves with a constant acceleration along a line. Shape of the graph with velocity on y-axis and time on x-axis would be option 1, straight line, option 2, rectangular hyperbola, option 3, parabola. Option 4, something else, let us say circle. Naturally, as I have explained in the previous graph, it's a body moving along a line with constant acceleration, so the graph should be a straight line because the slope should be constant. So if you know b is equal to u plus at, or if you know that the body is starting from rest, let us say u0, v is equal to at, which is in the shape y is equal to mx, so you should be getting a straight line. So this is how, and one question I explained to you. Similarly, you have a formula h is equal to t cos theta by RdG, where h is the rise of liquid in the capillary tube. This question also I have seen many times in different exams. What is the shape of the graph with height of rise of the liquid in capillary tube versus radius of the capillary tube? H versus R, h on y-axis, R on x-axis. Now, from the formula h is equal to t cos theta by RdG, you have h and R inversely proportional. So the graph should be rectangular hyperbola. Suppose you have de Broglie wavelength, lambda is equal to h by mv. What is the shape of the graph where de Broglie wavelength versus momentum of the particle? Again, lambda is equal to h by mv. Your graph should be rectangular hyperbola because lambda and momentum are inversely related. So, then the next one, parabola. You have a relation Ek is equal to p squared by 2m. Kinetic energy and momentum are related by this relation. Suppose a question is set like this. What is the shape of the graph for kinetic energy versus momentum of a body? Options are straight line, parabola, circle, ellipse. Your answer should be parabola. I am just cautioning here. This is the only area, as far as the shapes of the graphs are concerned, you should be cautious at +2 level. Usually you don't get other types of graphs such as circle, ellipses, things like that, depending upon the mathematical equations you have in your physics formula at +2 level. If you see the relation Ek is equal to p squared by 2m, it's clear that Ek and p squared are directly proportional. So if you plot a graph for Ek versus p squared, you should be getting a straight line because they are proportional. As I told you, for all proportional quantities, you should be getting a straight line. But if you plot a graph for Ek versus p, it should be parabola. I think you understood. Similarly, from simple pendulum, you have the relation L by t squared is equal constant, or L is equal kt squared, let us say. So L is proportional to t squared. So what would be the shape of the graph for L versus t squared? Straight line. But what would be the shape of the graph for L versus t? Parabola. So this one difference you should be cautious. So from your syllabus, even you have to understand that the shape of a graph is decided by the mathematical equation governing the formula. You don't have formulae of the type x squared plus y squared is equal to a squared, which represents a circle. So you don't have chance of getting a circular graph by and large, except very few instances here and there. Probability is very remote. So as far as the +2 syllabus is concerned, you have 4 graphs. So if you know when do you get a straight line from origin, and if you know when do you get a straight line with an intercept, and if you know when do you get a parabola, and if you know when do you get a rectangular hyperbola, your mark on graphs is yours. So as I told you, you have chances when a question is set on a graph. As I told you in my last class, I am repeating, you have 4 possibilities. The question may be related to slope. The question may be related to area. The question may be related to nature of the shape of the graph, such as the ones I discussed in the last part of this video. And the question may be related to the interpretation of the shape of the graph. So if you are thorough with all these aspects, the mark is yours.